Now that we have an entire dialogue system that more or less works in any way that you could want it to work, we also want to add one last thing, and that is the ability to remember what you have set to a certain character. Because this can be important for just gameplay reasons. If you already have gone through some introductory text, maybe you want to save that text has already been done, and then when you come back to the same character later, he's not going to do the same entire thing and whatever. I'm not going to go over saving this to a save game object, because that is more like general knowledge that I would expect you can probably find elsewhere. I have a number of videos on actually setting up save games on my channel as well. We've gone very in-depth with setting up more complex save files in my inventory course as well, which I could highly recommend to you. So we're just going to go over the communication between the dialogue tree and getting those out of that, putting them in a place in the dialogue component, and then getting them out of that dialogue component again to set them back into the behavior tree when we run it again. After that, it is literally just a matter of saving out the variable on the dialogue component to your save file. So I'm not going to waste too much time on that portion of it. Anyway, so in the dialogue component, we want to have a thing that allows him to remember what choices have been made. And the way that we're going to do that is we're going to make a new variable, and we'll call this choice memory. And the type of this is going to be an integer, and we're going to make this an integer map. And this is going to be kind of funny, because oftentimes when you make a map, you have a different type of key and value. We're actually going to have a map that takes in an integer and gives you back a different integer, because we're going to be saving the choices, choice 1, choice 2, choice 3, choice so on and so forth, and then corresponding to that will be the actual value of each choice, both of which just happen to be integers. So let's make a new function, and that will set choice memory, and that will take an input of the new memory. Let's just call it that. And that will also be an integer map with an integer value. So all that this is going to do is it's just going to get our choice memory. It's going to clear it out, just in case there was any old data in there. And then we're just going to set its value as well to the new value that we provide in. And that's really all there is to it, not much more. Because all the rest is going to be happening in our end dialogue behavior tree task. So we go over there, and at the very end here, before we stop logic, we didn't even end with a finish execute because it doesn't matter. We're going to make a new function in this, and this is going to be a function, and that is not exactly relevant, but is good form, because we want to be able to use a local variable, a variable that gets created when the function gets run, and then discarded when the function is done running, so that next time you run it again, it will have a new fresh value. You can just do it as an event in this case, because it's on a thing that's just going to run once and then the entire object is going to get destroyed, so it doesn't matter that much, but it's good practice to get into the headspace of when to use functions and how to use local variables as well. So we'll use this to remember choices. And we'll also add a variable here called choices to remember, which will of course be a Blackboard key selector, but we're going to make that an array as well. And the reason we do that is so that we can choose exactly which choices to remember at every endpoint of our tree. Because sometimes maybe we want to remember more, maybe sometimes we want to remember less, maybe sometimes specific parts need to be remembered or not be remembered. So that's going to be exposed as well. And now things are going to get a little bit tricky, but bear with me, we're going to get this done. We're going to make a local variable, and this will be our temp map, is just what I'm going to call this. And this will be a integer map with integer keys, just like all the other ones. And this is where we're going to be constructing the map, and then we'll just send it through to the actual character in a moment. So the choices to remember, we're going to for each loop over those. And if we want to remember every single choice, that is quite easy, because we can just say, hey, add these in the right order, and then just set those values in here. But what if you only want to remember a certain few of them? Because of course, maybe we don't want to remember the last choice, so that we can start redoing that choice over and over and over again. And there, just having this Blackboard key selector thing is not quite enough. We're actually going to make a struct to provide us with what we need to do. So we can go blueprint, make a structure, and call this something like blackboard key with index is what I'm going to call it, because that is very descriptive of what we're going to be doing. This will be a blackboard key selector, and we're going to add a new variable to it, which will be an integer for the index or the choice that it corresponds to. So we'll call this something like choice index, and we'll just call this something like key. And now that we have that little thing existing, we can actually change this to the blackboard key with index structure instead, which will change some things around ever so slightly. But now, if we look at this, we can break this, and we can see it breaks into a key and a choice index. We'll see in a moment what that looks like in the actual behavior tree graph. But now what we can do is we can add at the choice index for the top one, the key, and then the value will be the key get value as integer. And we can put that in as the value. So now if we say, hey, choice number 3 and 5 and 9, we want to remember, this is going to only add choices 3, 5, and 9 to the map in a way that we can still read them back with their corresponding values. Then, as an input to this function in, again, we're still in BTT and dialog, we're going to take in the dialog component, which will be, of course, a dialog component object reference. And since we now have a dialog component object reference, we can set choice memory once this entire for each loop is completed. So not in the loop body, in the completed bin. And that takes in the new memory, the thing that we just created, and that'll be set there. So now we have a way to say, hey, remember these choices and set those to the dialog component, which will exist even after this behavior tree has ended. But of course, now we need a way to take that information and put it back into the blackboard, which is a little bit more tricky, I will admit. So there's a handful of ways to do this. And honestly, the easiest way to do this is a kind of a cheaty way, but it is also the most stable way to do it that I have found so far for this. So we're going to put that into the behavior tree itself. So before all this, we're actually going to put in another selector, which will have a different task here. That's just going to be running one time, and then it's going to close itself off for the rest of the duration. And all that is going to do is it's going to load in the values of whatever we have saved into the proper choices. So let's make that task real quick. We base it on BT task blueprint base, remember choices or something like that, which of course will start with a receive execute AI. And then we're going to be making a variable here for the input keys, which will be of type blackboard key with index, and that will be an array. And we're just kind of going to set that up the same way, right? So at the execution of this, we're going to for each loop over this, but not before we also get the controlled pawn and we get the dialog component from that. We can check whether or not that's valid, just to be sure. And let's just promote this to a variable real quick, so that we have easy access to it if it is valid. If it's not valid, I guess we can finish execute without success. The only thing that we actually really need is the get memory choice. So instead, maybe we can promote that to a variable so that we don't need to keep this around necessarily. Because the only reason that we are keeping that around, frankly, would be to access the memory choices. So we might as well just set that to a variable directly. Then in the loop body, we're going to break this thing. And then we're going to be setting the value of the key as an integer. But what value are we going to set it to? We're going to set it to the value that we get out of the map by providing in the choice index. So if we go map and we don't have a get function, actually, it's called find for a map. We get this choice index, and only if it is something that it can find will we set it. Otherwise, it's going to mess up some stuff. But if we can find it, this is the integer value that we're going to be setting it to. And after that is entirely done, at the end of the for each loop, we'll just set success to true. So now we have this thing that will get a bunch of input keys with their corresponding indexes and set their value from a map of memory. So we can remember choices, again, only after it's been initially saved. I always forget that. And now we want to add a decorator to this for a Blackboard key, a Blackboard key that does not yet exist. So we need to make a new Blackboard key for this, and this is remembered keys or something like that. It should just be a bool, and that will be what we're going to be checking. So we check the remembered keys, and if this is not set, so if this is false, we run this, and if it is true, we can't run this, so it'll just run the actual tree itself. The reason we do it this way, instead of just doing it in the run dialog tree here, like we have the run behavior tree, is you kind of get into a situation where if you first run the behavior tree and then start setting values, it'll already have gone through and gotten stuck on this with the default values. So you want the behavior tree itself to take care of that. And also we need to be able to like access these input keys that we have here, to say which index that we give in corresponds to which key, because outside of the context of the behavior tree itself, it's kind of hard to figure that out. So this is really the easiest way to set that up. That said though, we need to expose some of these keys. So we need to expose the input key array, and then we also need to make a singular remembered key, because that's going to be type Blackboard key selector, just a normal one, which will be a single value. And then at the very end here, before we do finish execute, we will set value bool, and we'll just set that value always to be true. So once this is run once, it's going to be setting that value to being true so that it can't run again. This is just kind of a run it once and then forget about it until the behavior tree itself restarts entirely, which of course also needs to then be exposed. So now we have the remembered key is remembered keys, and now we have a bunch of key inputs where we can say, hey, which key do we want and which index does that correspond to? So let's go to the end dialog for these ones over here, and we say choices to remember will be choice 0 and then 1 and then 2, for instance, which will be choice 1, choice 2, and choice 3. Again, you can very much label these as 1, 2, 3 because they're all being set to a map, not to an array. So these indexes aren't like actual indexes, they're keys technically. But we don't want to actually remember choice 3. I just remember we only want to remember choice 1 and 2. So I'm going to just do that, and then we end the dialog there. So now that we do that, it's going to remember choice 1 and 2 if we exit through one of these two ends. And as a matter of fact, I'm just going to only remember choice 1 if we go through I am your father. And we're going to remember both choice 1 and choice 2 if we go through this to show you the difference between the two of them. Then all we need to do is in this remember choices thing, we do actually need to set all of them up. So that would be choice 1 would be 1, choice 2 would be 2, choice 3 would be 3. We're not actually working with choice 3, 4, and 5 at all. So you don't really need to set this up, but it's probably good to just set this up like fully like this. Of course, if you need this to be somewhat less variable, you can just set these as the default values. Just kind of like drop it in, set it and forget it kind of thing. But with all that now, we should be able to remember our choices. So let's go ahead and see if that works. And set our choices. So I am your father, and then he's told me enough, he told me you killed him. That will end this behavior tree. And then when we run it again, it starts at what it remembers. So it starts at no, it skips the first choice that we made because it still remembers that because it's loading that back in. Now, if we go through this again, we can once again choose he told me enough or he told me you killed him. So we can make the same choice again, he told me enough. And this time, instead of taking the first one, he told me you killed him, we'll take the second one. You are my father, which will say that little snitch. And now it will have remembered the first and the second choice. So we'll only get the option again for the third choice. So what did he tell you? And we're back here. Funny thing is actually, if we just told you killed him, it's going to only remember the first choice. So this way we can actually back up into the behavior tree again. It starts at no, because every time we do this, it clears all the previously remembered stuff. So this way, we can remember what was said in between, and we can go do whatever we want. And as long as at least that actor stays loaded, it will remember that stuff as it should be. If you want to be able to unload and reload the actor, you're going to need to incorporate a save system to save that map, which is relatively easy, to a save file. But for now, that means that we have a working dialogue system, and this mini-series is coming to a close. Once again, maybe in the future we will do something a little bit more advanced, like making custom assets with a custom editor, if we really want to take a look at that. I think that the setup that we have here is going to be enough, and for a lot of people actually preferable, about like 95% of the time. So hopefully you're gonna have a lot of fun writing all your dialogue and putting together all your dialogue trees, and I will then see you all back with whatever we do next. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. A huge thank you to my Cave Digger tier supporters, Sir J. Thomas,